I think we'll be starting the first session on epidemiology, biostatistics, and research. And I welcome all of you to the session. It will be better if everybody can give a bit of introduction, their expectation. I start with myself, Dr. Rajesh Mehta. I've retired as a dean of a medical college, and my current main focus is on online education, virtual medical education, and so many other activities online. And also, innovation is my passion. I'll be talking about it later on. So, I would wish that uh, you also introduce about yourself, and then we'll be starting our introductory session. And when you give your introduction, it will be better if you specify a purpose of joining. So I think who should speak first instead of that? Whosoever feels like that, you can start. Or yes, can start introducing. Unmute your mic and then you speak it out. Yes, please unmute.
Hello, sir.
Yeah.
Myself, Yash. I'm from JMC Akola. I have background. I'm working as a statistician from last 4 months in Government Medical College. I have my background from pure mathematics, that's statistics, and this medical field is quite new for me. So that's my purpose to uh, attend this course to know better about epidemiology and biostats. Thank you, sir.
Yeah. Someone is asking whether it will be starting from sketch or not. Yeah, it will be starting from very first session only. So, but anybody can join. There's no problem. So, and it will be a first session because there are two sessions going on. One batch is halfway, and they can also join over here, and you can also join middle also. There's no problem because two batch are going on simultaneously. And in future also, all of you are welcome to join any session on statistics because it's not that once you join and the skill is khatam. So the purpose is basically to foster the uh, research mission all over India and then gradually to all over the world. We want to unite the world through the database, and each one of us will get a benefit out of sharing the database. Of course, it will be anonymous, etc. But then if we work together, then probably each day, not each day, each second, there could be uh, the research will be useful to the world. So it will be Yash will be our faculty also for purpose of statistics, but you will learn a lot of about research and epidemiology in terms of infectious disease epidemiology, then the non-infectious disease epidemiology that will be very useful for you. So someone else can spell out. Someone having the name is not written is written as Redmi, Redmi. Can you introduce yourself?
Hello,
We can't listen you.
hello,
Yeah, please. Yeah.
sir. Hello,
Hmm. Yeah, please.
can you listen me?
Yeah, we can.
Okay. Myself, Dr. Amrish Soni. I am working as a medical officer, homeopathy medical officer at Patri district, Surendranagar from Gujarat. And I am recently PhD scholar in homeopathy, so I have joined it.
Yeah, it will be very good for to connect with you because across the pathis, we would like to have some database common that where who has worked and pathi has worked or someone else has worked. Very good. Welcome, Dr. Soumya. Dr. Soumya, can you introduce yourself?
Good evening, sir. This is
Yeah.
Dr. Soumya. I am Professor of Microbiology from Sridevi Medical College, Tumkur, Karnataka. And I have joined this course because I want to improve my knowledge in biostatistics. Now, how much ever I read biostatistics, it seems confusing to me. So that's why to improve my knowledge in biostatistics, I've joined this course.
I'm sure that at the end of this, on 15th August, you can declare yourself that you are a teacher for the statistics, epidemiology, as well as research methods. It's very simple. We'll
Sir.
be going for the basics. And I remember my interns somewhere in 1989 who did a very good survey in the microbiology, which bacteria are common, and for that bacteria, which antibiotics is common, like that. No, during internship, people did that.
Okay,
But
sir.
for the test of significance, etc., we are using the AP Info software, which is such a user friendly that you would like to use that software so often. Dr. Bala Subramanian?
Hello, good
Dr.
evening, sir.
Bala, good evening.
I'm Dr. Balasubramania from Sharda Institute and Paramedical Sciences. I'm a PhD scholar of biochemistry. I want to increase my knowledge in biostatistics. So I have joined.
I was thinking of vitamin A level. So biochemistry, people can do the vitamin A level. See, one of the my instrument which I have found is detecting whether you are having vitamin A deficiency or not. It is measures in terms of millilux, while you people will be able to measure the vitamin A in terms of, let's say, nanogram or something like that. So both of us can work together and find out whether there's concordance or not, or we can find out some equation, and based on the equation y is equal to plus x, like something like that. That equation we can find out, we can predict the vitamin A level based on the non-invasive method which we have found is basically a instrument which doesn't require any blood to take it out. It's purely based on the electronics and the mechanism. So I think we'll be able to work together. Uh,
Sure.
Rupashri,
Good evening, sir.
good evening.
This is Dr. Rupashri. I'm working as Associate Professor in the Department of Microbiology in a medical college in Tumkur, Karnataka. I've joined this course because I want to improve my knowledge on biostatistics because I'm a member in scientific research committee of an institution and my knowledge as such is very basic now. So I want to improve the same.
I'm sure that your student will benefit a lot from you because you're in the scientific committee. You will be able to involve them. And I request all of you to find out at least 10 individuals whom you can talk about the statistics, research, epidemiology, etc. Ayushi Singh,
Good evening, sir.
good
Myself,
evening.
Dr. Ayushi Singh, and currently I'm working as a medical officer at Samved Hospital. And the main reason for me to enroll into this course is because I've always been fond of research and its activities, and I wanted to learn more about it.
And if by chance Samved Hospital gives you access to the data, at least for the
Yes, sir.
purpose of academic, then
Hmm.
you can simply find out the X-ray positive, negative, MRI positive, negative, CAT scan positive, negative, and then the organ-wise. Even this simple analysis will give a lot of insight. But then you need not do a research only on a single center. If in multiple center, that will be better because single center, if you do it, it will may improve the image of the center or maybe ruin the image of the center. So if we combine, let's say 8 to 10 centers, it will be better. And I request all of you to join multi-centric research study. So one of the purpose of various people involving so that we can have data across the nation, and that will give a lot of insight. Uh, Dr. Radhika,
Hello, good evening, sir. I am Dr.
you're good
Radhika.
evening.
I am from dental surgeon. Sir, I am dental surgeon from Indore, Madhya Pradesh. I'm currently pursuing my MBA in public health, and I want to increase my knowledge, so I joined this course.
There's only one organ in the whole body for which there is a separate college, that is the dental. There is nothing like eye college, nothing like ear college, nothing like heart college, etc. But there is a dental college. It means that there's a lot of importance for the dentistry, and I welcome you for that purpose. And let's now start with the introduction. And it will be much better if you can interrupt me anytime. Let there be as if we are sitting in a circle and talking to each other. That will the clear a lot of things. And sometimes if I tell you to respond by writing in the chat, do that, right? And after, let's say, 2, 3 minutes or maybe 5 minutes, I will tell you to do that, because we start with uh, the the three topics together. Generally, people talk about epidemiology or maybe biostatistics or research as a separate subject, but these three are so much interwoven that it will be interesting only if we take it together. So, and I love this subject basically. I enjoy while I teach subject, and and probably you will also enjoy it. So, purpose of learning. See all these slides, etc. I'm sharing with you. I don't mind if you share it further. I expect that all of you will be teach at least 10. If you are a UG teacher and training 150 students, no problem. The slides will be given to you. So basically, you should be enjoying your life. So if you currently feel that you are not enjoying, you have lots of hurdle and lots of things, forget that and enjoy. See, the philosophy is that the Atman which is within you is basically a source of a lot of joy and the happiness, peace, etc. You can tell me where is the proof. So I'll give you proof. You like ice cream, you're taking ice cream and you are enjoying. So is this a joy in ice cream or in your mind? No. Is the joy coming from inside? Only thing, if this is a ice cream, is only a, say, is a nimit, what we say is an article which becomes instrumental in bringing joy from your Atman. So basically the source of Atman joy is only Atman. And that's why if you agree to this philosophy and pay attention to little bit, then you will say, yeah, life is full of joy. And the statistics in mathematics. See, mathematics is 1 is equal plus 1 is equal to 2. That is a mathematics. But if any figure which is near to the 1, add another figure which is near to the 1, then answer will not be 2, but answer will be near to the 2. So that probability, where it lies, that we are finding out with the help of statistics. So the life is not only full of mathematics, it's also full of statistics. And this probability comes in biology much more, because whether this treatment will cure or not patient is 199 patients are cured out of 100. The probability that the next patient will be cured may be 0.99. But once the result is there, for that patient, it is 100% failure or the cure. So we can only talk about the probability to the patient, and the decision making process can be based on probability. And other thing would be learn how to build an opinion and give it to others. When patient comes to you and patient asks you a question, doctor, what is the probability that I will be right? Whether I should go undergo the operation or not, whether the joint pain is there for last 7 years. Now, whether I should go for operation, replacement of the joint, or whether I should go for an Ayurvedic treatment or a allopathic treatment, something like that. At that time, you have a data analysis ready with you. You'll be able to answer, talk frankly with the patient, and your role will be just giving a various options, counseling, not the decision. Decision making process should be basically based on the patient's perspective, except in case of emergency where you need not ask the patient whether you take a decision or not. Then once you learn this technique and if you practice it, you'll have a better job or better business. Even you can calculate the probabilities in case of share market, etc. also. and the purpose of the life, whatever you say, finding out the ultimate truth. And this sessions will help you into finding out the ultimate truth. Now, game of judgment, everyone I would request you would try to play a game of judgment. For example, I will tell you assess my age, or if I tell you that assess the weight of someone else, or you can say the what will be the pulse rate of individual before you take calculate exact pulse rate. Just take this many pulse. It seems to be around 82. Now actually calculate with the watch. 1, 2, 3. And then if you find it 86, then again measure that next time I should not talk it 82, this is 86. So first judge approximate value, then find out and measure it exactly, and then refine your judgment clinical. If you do this game of judgment, if you play, even students plays, then if you just play this game 100 times, try to find out if it is the weight of 100 individuals. So initially you may be wrong by plus minus 10 kg. But then the moment you did it for 100 people, then your judgment will be sharpened and then you will be right most of the time plus minus 1 or 2 kg only. So there are so many parameters. And this game of judgment at some point of time, then you will be able to develop your sixth sense. And sixth sense development is very important in case of the medical the field. So this is something which you should try yourself as well as PhD students. Then these are the certain topics whereby all of you can join in learning, and the everything is beyond my comprehension, but at least I will be able to facilitate you, giving you in context of the experts. So machine learning and artificial intelligence. The statistics is very useful in machine learning, and the artificial intelligence both are working in the terms of probability. What will be the future plan? It can find out. And the scientists are right now the experimenting how the brain is working. Brain is a modern supercomputer, and how the neurons are taking place. And each and every neuron, right? They are doing some function where is the what how the memories take place, how they interconnect, how they communicate to each other. Right now, experiments are going on that instead of so many leads in EEG, at least putting only few the roads, you may also talk about EEG and how much depth it is there, the lesion is there, that they can also find out, and they will be able to cure also with that nano frequencies. This science is uh, working so at a high level, and this knowledge of statistics will help you in that process also. Image processing right now, endoscopy, etc., are there, and based on that, the even for example, you find out the color of the tongue, or you can find out the color of the stomach, or the image you can take during that while you examination of the rectum or the vagina, etc. All this will help. And non-invasive versus invasive tests, the next era, next 5 years will be the non-invasive test, because now because of the invention of the nano frequency, you can find out exactly which molecule are there in the blood, the level of the blood glucose, level of urea, level of creatine, etc. At that time, you are going to compare with the blood levels. And when you compare the blood levels and the level you shown by the non-invasive technique, and you need to find out what is the correlation coefficient. If correlation coefficient of 1 is absolute correlation, and if it is near to the 0, there is no correlation. Let me talk about the example over here, which is my favorite example of the correlation. A physician, one resident doctor, not a resident, but he is a physician. He was physician. Brought out a very good data that based on urinary creatinine level, he could judge the glycosylated hemoglobin in the blood. And he came that let's go for research paper, Dr. Mehta. How do you find it? I applied these statistics with help of EPInfo, removed the compounding factor of the age, and found that there is absolutely no correlation between these two parameters. So when some result is there, but if you don't know how those statistics to be applied, then hardly you will be able to do the research without the help of statistics. Now, the thing is there are multiple factors and complexity is increasing day by day. If you talk about 40, 50 years ago, there are hardly few factors, few food articles in the market, etc. But now, lacks of food, the preparation in the market, lots of molecules in the environment also because of the pollution, and which factor acting when. Let's say for autoimmune triggering. Autoimmune problems triggered by the COVID-19 made a chaos like anything. And at that time, people understood the difference between the people who were healthy, real healthy, and not. Even healthy people, if their immune system is strong, but then when it fires to convert it into the autoimmune, the so fast their death will be there. So this type of complexity to find out the something out of that, you require statistics. And our purpose of life, my particular purpose of life is to unite with the Almighty before, if possible, before I leave the world. But then the human concept is important for us. In somewhere around 1990, 91, around 91, we coined the word human health circle. So human homeopathy uses universally Unani and all other system like Reiki, Sujo, like that. AM is a modern medicine in which I did my MD, is Ayurveda and N is naturopathy. So combine all the pathies together, we should be able to give the best to the world and worst of none to the world. So across the various sessions, we'll be talking about this also. And now the thing is, somebody says that these people require knowledge, these people require something like that. But whether they require or not, what is their perspective? And this for the same problem, perspective can be different. So before you jump into the research, you should be defining the things, defining the problem, and that's the epidemiology. Whenever you want to apply the epidemiology, you need to have a very clear-cut objective definition for that. And while the perspective we are talking about, there are sometimes malpractices also increasing over a period of time, and people's intention, or sometimes the company's intention, or there could be a bias in doing the research, or some of the research are fake. It's done just for the sake of the dissertation purpose. One, the young doctors came to me and said, "Sir, please, I have only few days left. I want to, this data to be analyzed and prepare tables." I looked at the data, and within few minutes, I talked to the person that I'm not going to analyze this data. This is fake data. With a period of time, you will understand how to identify fake data. So there's no point in wasting our energy for analyzing the fake data, no matter how much money they give you, but don't use this knowledge for analyzing of the fake data. Now, when we talk about epidemiology, let me make it clear that the epidemiology is basically a science, right? We study the population, basically determinants and distribution. In distribution is the time, place, person, what time, where, and who are affected. In that, so many characteristics. And determines why this happened. There is a cause behind all the events. And to find out the cause, there's the epidemiology. To find out distribution and determinants of disease or health event. That we cover under the epidemiology in specific population, etc. So I'm going to ask you one question in chat box and you need to answer. If I want to study epidemiology of hypertension, can I study that? Write down yes or no so that I can find out. In meeting, yeah. So just write down the answer yes or no. Can I do the epidemiological study of hypertension? So let me know how many of you are very alert. Yes. At least 3, 4 answers should have come fine. Okay, 2-3% is 2% said yes. Now, next question is epidemiology of. I want to study the epidemiology of headache. Can I do such study? Can I do such study? Yes or no? This question I should have asked to everyone, right? Yeah. Can I do epidemiological study of headache? Yes or no? Once you answer this, at least 3-4 people. Yes, then the Bala Subramaniam, so many people are attending. If you don't give answer, there is no charm in moving further. Or you write down, do not know, right? Or you can write down, do not know. At least write something, do not know, or question mark, something, so that I can find out whether you are Radhika. Yes, yes, I used to sing. Then, anyone else? Okay. So the answer would be you can do the epidemiological study of any health event, whether it's a symptom or sign or investigation, there's no problem about it. The only thing that you should define it clearly. In case of if you want to study the epidemiological study of abdominal pain in this, let's say the Gadchiroli block of the Maharashtra, if you want to do that, yes, you can do it. But which subject you're going to include, what kind of abdominal pain you're going to include, duration, etc. If you can define that, then only you can do the epidemiological study. Otherwise, would not. So the answer would be yes, but with definition. So we'll be talking about basic tools in epidemiology, case control study, odds ratio, and then the relative risk, attributable risk, contributor, the population attributable risk, etc. And the basic purpose of learning that, so I like the most is a population attributable risk, because in a given a population, if you want to remove a certain factor, how much advantage you will have. So at some point of time, all of you need to do one exercise is a web of position and web of effect. That will tell us where to work, how to work, when to work, like that. And this, for this purpose, for epidemiological study, when you are doing a research study, you have some kind of epidemiological design, long term, short term, whatever it may be, or retrospective, prospective, and appropriate statistical tests when you apply, right? At that time, you can do the research. The concept of causality, this association and causation. In your case, all of you are supposed to think on the some kind of project proposal, which we may take up to 4-5 sessions. But in that, you need to find out whether it's a simple association or there could be a causation. So there is a various criteria for the causality, and that we should keep in mind. And very important thing that I will give an example, a story over here. And I will write that in chat, and you need to answer. The people of village, uh, they keep it the concentration over here. People of one village were telling that by sleeping under the banana leaves, you will get you will get watery blood. They say loino pani thai jai. It becomes blood becomes watery. This is their thing. By sleeping under the banana leaves, you will get watery blood. Now, this is their belief. Now, do you think this could be right? Right? You can answer like this: yes, no, or maybe something like that. Sleeping under the banana leaves, you get watery blood. Blood is converted into the water. Few more answers. Few more answers. Okay. Now, the thing is, it is their observation over a period of years together, their observation, that this happens. Now, when we talked about the teacher, great teacher, Dr. N.R. Mehta, who studied under the Dr. Niyogi, he worked with the Dr. Niyogi. So, and he explained that the sand in which the banana plants are grown is very sandy, and there is intermittent water supply. And this is a very good media for hookworm eggs to grow and develop into the larva. And these people defecate in open. And so there are lots of eggs of hookworm is there, which convert themselves into the larva. When they sleep under the banana leaves, they pierce the skin of the individual from not only from the foot, but from all of the body once they sleep over there. And this season, and lots of hookworm will enter into the body through the skin. They go into the circulation, then go into the lungs, then they go into while coughing, they come into the throat and they go inside the intestine. And here they suck the blood from the intestinal villi and they make the person anemic like anything. So ultimately, it was an observation of the villagers, and really it was a cause, but cause was they related with the banana plant, but actually that was because of the hookworm. But in a sense, their observation was correct. Yes, anyway could be there. So in search of causality, you should be able to try to find out if it is really related or not. But if you do not know, just do not know, say don't throw out the theories. People say that by taking a banana, you will have cough and cold. Allopathy doctors, what they will say? This is a humbug. It cannot be like that. But who has done an experiment? Based on the prakriti of the individual, to try to give the banana and find out if this is humbug or not humbug, right? So I don't say that you accept the as it is or you reject as it is, but try to think over and try to do the study or float the question over the floor and then try to find out whether it is correct or not. And we'll also talk in detail about the prospective and the retrospective core studies, randomized control trial, etc. For this sensitivity and specificity, I'll share one video with you on YouTube. Then it will be much easier for you to understand. And few slides on outbreak investigation. In outbreak investigation, we have a very good story to say that in Anand district of Gujarat, we had surveyed 2,000 cases of the hepatitis A. And we could establish who was the first case who came from the outside the Anand, and from that it sparked whole Anand was the affected, and we could find out the various intermingling the sewage line with the water line, and there was a classical outbreak of the hepatitis A. So it is possible if you go into detail outbreak investigation to find out the cause. Then there is another story in the outbreak investigation in Madhya Pradesh. There was a village where lots of cases of hepatitis were there. They could not find out any water problem or any grossly food problem. They cannot find out. But then Dr. D.S. Trivedi, who was also happened to my teacher, he could found out that a resting soap is giving a very, very bad food. It was full of aflatoxin. And for prolonged use of aflatoxin, spoiled the liver of so many people in the village. And that's why there was the epidemic of hepatitis. So meticulous data recording and analysis is very useful for that. In terms of statistics, as I told you, we'll be using the various tests, but in that, the main emphasis should be how to identify the variables. The moment you know that these are the variables from which you can find out proportion, and these are the variables from which you can find out the mean. Once you understand this, 50% is statistics over. Yeah. And based on that, you will be able to do the data analysis further, whether the test of proportion is to be done or test of the mean you are supposed to do. So this is so simple. And when you use AP info, it will be further simple. Other word is the normal distribution curve. Now, if we use this word instead of that normal, if you use the word usual distribution curve, another 10-20% problem will be solved in statistics because the normal distribution curve doesn't say what is a normal. That is a myth. Most of the UG students have a myth that if there is under the normal distribution curve is a normal, beyond that is abnormal. If this is the case, then in whole over the world, you will have a 2.5% hyperglycemic, 2.5% hypoglycemic. Hypothyroidism 2.5%, hypothyroidism 2.5%, hypercholesteremia, hypocholesteremia, like that. So everywhere you will have 2.5% if that is the case. So is not that normal distribution curve suggests the normal thing unless you categorically find out the normality based on another parameter which is under the study. And then you find out the normal curve, then the another normal curve, another normal for the different categories. Then you can find out the borderline, how to find out what is the normal blood pressure, how to find which is normal blood sugar level. That is to be done meticulously with a long and large study, and that is possible by us also if we have a data collection together. And the p-value is always the problematic. More the p-value, less the significant, lesser the p-value, more the significant. That's why remember the p is nothing but a probability of event occurring by chance. I repeat, p is a probability of event occurring by chance. So if by chance this is a less like that it is by chance, then there's some significance. So instead of the word p value, if you translate in yourself that p is a probability of event occurring by chance, if you remember this, p value becomes a simple. That's why people will say that p less than 0.05, then the probability of occurrence event by chance is less, then you say it's a significant. Another thing is probability is out of 1, while the percentage out of 100. So whenever you draw anything, probability we are taking total population is equal to 1. And that is a unit. And that's why it is equal to 1. Then you can apply it for 10,000 population, 1 lakh population like this. You measure in terms of kilometer, you measure in terms of kilogram. Similarly, in statistics, we measure the distance in terms of standard deviation. And standard is also one kind of standard deviation that we'll see. So these are the few concepts in statistics. If you learn it, then it becomes a left-hand job. Then there is just like a differential diagnosis we are using in terms of fever or diarrhea like that. If you're given example, which statistical test you're going to use it. So we'll be using the diagnostic flowchart. Based on that, we can find out which statistical method should be used. And there are other software which I may not be able to take it over here, but I would like you to see that Open API, the such software available. And I recommend that if possible, try to go for open source software. So it is easier and the financial also burden will be less. Then all of you should be keeping your data set ready. Even in Excel, it's all right. Keep it ready so that from From the next session onwards, you start analyzing the data. And the advanced statistical test is out of purview, but at least we'll take few examples. And those who would like to go for much advances, they should refer the AP Info manual. And next time you should be downloading that software too. And if you know the data relational database from the of the, let's say, few the different databases, and you know how to relate it with the primary key, it will be much easier. I will give an example. You have a data of the district, your data of the taluka, your data of the families, your data of individual. But automatically, how to add the data of family into individual, how to add the data of taluka into an individual. If you know this, then the analysis becomes more delicious. You'll be able to have better interpretation, etc. For example, in a house there is electricity, no electricity. In a house there is water supply, no water supply. So all these variables, once you write under the family form, you need not write under the each individual form. Individual form, if staying in that family, the primary key of the family and the primary key of the individual is the same in database, you should be able to do relate the data. And that will be very useful if you learn that in the AP form. So in under the research, each one of you are going to do the complete project. And the teaching will be over when you ask a question till teacher cannot answer. When you ask a question, if I can't answer, that means I have taught you something. So let us get an example of the WHO software, right? And that WHO software you should be able to download, else we'll be able to share you the files. And the this 23rd, the national program, we wish all of you that keep someone ready to learn this. So while I open the AP Info software, you can ask few questions. You will have AP Info software, you will launch the software, and I wish that all of you download this AP Info software. I will straight away go to the classical analysis. And there's a party. Anyone having the birthday during this month? Birthday in July? Any one of you? Please answer over here. Anyone having birthday date in July? Or August? We are planning to have a birthday party at that place. July or August? No one. Then next is September. Yeah, August 11, Radhika. So where do you stay, Radhika? Unmute yourself if you can do it. Probably you will not be able to do it, but we need to come to your place. And Okay, you can write down your place. Where do you stay? Indore. Okay. So let us see that all of us gone to Indore in the party where Dr. Radhika stays. And unfortunately, we 75 people were there, but few people felt ill. So we look at the data in EPINFO, and the data says that various age factors, sex factor, gender, etc. And some of them fell ill. And in party, a lot of food articles were there. And we want to find out why some of them fell ill, why all were not fell ill, right? So that data we have of 75 individuals. And we first start doing frequency, just frequency start. So before we think anything over here, the database is ready. So analysis is ready now, right? It gives you almost all the frequencies are there. How many fell ill, gender-wise analysis, patient number, serial number, whether it's duplicated or not, very fast. And it is the age, and cumulative age is also there, 50 years. 66% were below 50 years. The highest one number was 70 years old person was also there. Then there is a how many were ill? 61% felt ill. But 38% were not ill. The gender distribution also given. So everything the analysis was done so fast, and all of you will be able to do this. And then we wanted to find out in tables command who felt ill more. For example, the taken coffee and then illness. We want to compare this too. So the result is out. You can see over here that out of 75 people, coffee was taken by 31 individuals, and out of that, 61% fell ill. Coffee was not taken by 44. Out of that, also 61% fell ill. So seemingly, it seems that coffee was not contributing to the illness. But I think you are sure. You may think that again the tables command fruit salad. That could be one of the cause of illness. And let's see whether it's related or not. But fruit salad was taken only by 6 individuals, and 66 were failed and not taken 60% failed. So there was no significant difference that we can find out from this data. The p-value is here, 0.7. So we can say that there is no significance between the fruit salad and illness. Now, I think you people love the vanilla. Let's go for the vanilla. Vanilla taken, not taken, very interesting, versus illness. So there's a big chunk over here, big green over here. If they've taken, they're filled. If they're not taken, they're not filled. This red and green suggests there's a lot of significant difference. It looks like, right? 79% fail if they took vanilla, only 14% if they have not taken vanilla. And now let us see what is there about the p-value. P-value is 0.000018, like that. So less than 0.05. So probability that this event had taken place by chance is much less. So vanilla seems to be closely associated with the illness. But in this case, if you can go on doing like this, but if you want to do the analysis together, right? Then you take a illness as a one variable. All this we are going to repeat. This I'm just giving an example that how we can do it. It will combine the 3-4 things together. Milk, then the gender, and then the vanilla, the rose, chocolates, right? You have selected this, and then when you go say, okay, this is a logistic regression analysis at a stretch will tell you which is the causative factor. In this, it says probability p-value is less than 0.05 in case of gender and in case of vanilla. Now, in this, you remember the odds ratio over here is a reverse 0.2 in case male female. That means male are much less affected compared to the female, and there's a significantly less affected. Males are less affected. And vanilla, 31 odds ratio, that means highly associated 0.000. The probability, it clearly says that it is more likely occurred because of vanilla. That association is very clear. So AP Info will quickly do the analysis for this kind, and AP Info has so many other things also. So I will stop the AP Info, everything over here. The purpose of this lecture that what we are going to learn, we'll learn epidemiology, we'll learn the AP Info software for that analysis, for statistical analysis, and we'll also do some discussion on the research methods. So now forum is open for questioning, and each one has to ask one question, and you can unmute yourself and ask the question.
Hello, sir.
Yeah, please.
So I have a question. What is meant by epidemiology? The first you ask question, we want to study the epidemiology, or we can study the epidemiology of some diseases. So
Hmm.
what actually we are studying? What we are actually trying to find?
Actually, when we say the epidemiology, that you need to study two things, distribution and determinants, right? Either of the health event or disease, and that is for the purpose of control the disease or prevention the disease in a defined population. So now you want to study, let's say, the diabetes, right? So you need to find out which age group is more affected, where it is more affected, Gujarat or which place, or which period is more affected. For example, which decade of stress, COVID-19, for example, there was a period of stress. Is that the time where maximum patient of diabetes suffered, or there's other time period? And in the longitudinal studies, we compare in terms of the trend over 10 years, what is happening. In a short disease like influenza, right, or COVID-19, in that we study in how much period, whether the accidents, for example, is more on the Monday or Sunday like this. So time, place, person distribution will be looking in epidemiology, defining the disease, and then the most important thing is multicentric studies nowadays. If you do that epidemiology study in a small place, your observation may be wrong. But if you compare across the other places, that will be much better. So in epidemiology, when you write down your project proposal, we are going to select the population, select the samples and the technique and the format development, everything will be there. Anything else? Any other question?
Hello, sir.
Yeah, please.
Dr. Soumya here. Sir, you spoke
Yeah.
about the AP Info software now, sir. Can
Mm.
we actually have the data in the Excel sheet and then transfer it to AP Info, sir, or the data has to be entered in the AP Info software itself, sir?
No, data can be there in the Excel software, in the Excel, and it can directly picked up by the AP Info software, provided you have headers only. If
Okay.
you are making the very colorful and the presentation type of AP Info, the Excel, that AP Info will not be able to read it. So now you should be able to keep the data very smooth. Header should be only one. There should not be merge cells. Then you can directly take it, and we'll see that how we can do it.
Data should be raw data, sir, or coded data?
Whether it's a raw data, coded, whatever you have, the same data will be you will be getting as output, and AP Info itself has an ability to recode the data. Suppose you have a data age group like 3 years, 4 years, 8 years, 9 years, like that. Within a single command, it can divide into groups, 5 to 10, 10 to 15, like that. It can recode the data also, if info. But I would say that whenever possible, when you have a data, this someone is using the video but not showing the face or something else, that video may be turned off. Who is this person? I don't know. Driving or something like that. Anyway, so the data should be given in the simple format in Excel. And sometimes the Excel you have is the latest version. Then you need to downgrade. You save as the lower version of the Excel. Then AP Info will be able to take.
Okay, thank you, sir.
Any other question? I think Shivani has not spoken at all. Or even Grivan has not, Victor has not spoken. You can introduce yourself, ask a question. Shivani, can you spell out your introduction? Even if you don't have any questions. Any other? So next time, keep yourself ready. You at least download the AP Info software and from the WHO website or CDC website. Us will be giving you share directly the installable files also. On Thursday, we'll go a little bit more in depth of the AP Info and few others, the topic, epidemiology, etc. But keep yourself ready with 8 to 10 questions at least. If there's no question, we can wind up. Any other question? Okay, thank you.